All right, so today we're going to be doing 9.3, which is going to be multiplying rational expressions. The rule for multiplying rational algebraic expressions is the same as the rule for multiplying numerical fractions. Multiply numerators, multiply denominators, and write the new fraction in simplest form. Multiplying two rational expressions produces another rational expression. Therefore, the rational expressions are what we call closed under multiplication. So when you see that terminology, closed under multiplication or closed under a certain operation, that means that there's no type of multiplication you can do that will change that result from being a rational function. So we know that the result will always be a rational function as well. Okay, that's what that terminology means. Before multiplying, use parentheses to group terms in the numerator and denominator. This will help you avoid error of canceling terms instead of factors. And then, do you remember how I talked a little bit about this on number 4 yesterday? How if you want to cancel something out, so see how we have a minus b over b minus a? Those are not the same factor, but technically I could rearrange the denominator so that it's negative a plus b, right? And then I could then factor a negative 1 out of the denominator, which will then leave me with negative 1 times a minus b, which will cancel out, but instead of completely canceling, it leaves me with, instead of a 1, it leaves me with a negative 1. So with that being said, you don't have to show these steps every time you do it. You can just see that they're like x minus 4 and 4 minus x, cancel it out, leave a negative 1 there. Okay, so that's what the gist of this tip helps with. Okay? All right, so the first thing you're going to do is you're going to end up writing it as one big fraction. So I put a big fraction bar there, and I'm going to talk you through each step individually. Okay? So the first thing I'm going to do is factor the one highlighted here. So what can I factor out of this expression? 2 and 2x. So I'm going to take out a 2x, and that's going to leave me with x minus 5, right? So that's that. Now, I already have something else on the numerator as well, the x plus 3. So I'm going to put the x plus 3 in there as well. Okay, because we're multiplying straight across, we're putting everything in the numerator on the numerator, and so on. All right, so to continue, thank you. Next thing we're going to do is we're going to factor the denominator. So I'm going to factor this piece right here. So I'll highlight it in pink so you can follow what's happening here, where that went. So how would I factor x squared minus 25?
X minus 5 and x plus 5.
Good, that's the difference of perfect squares. Do you all remember difference of perfect squares? And then lastly, this can't be factored, so I just leave it as 2x squared. Okay? Now, for everything else, we're going to first find any restrictions before we start canceling anything out. So to find restrictions, you're going to set your denominator equal to 0, basically. So anybody know off the top of their head, without doing the math, what 3 restrictions exist here?
5, negative 5, negative 2.
You're close. 5 and negative 5 are right. But what would happen, what would be a problem here if x was what for this term? 0. Because isn't it true that, what's 0 squared?
0.
What's 0 times 2?
0.
So for that reason, that would give me a 0 in my denominator. We can't have that. So now that we found our restrictions, does everybody understand why those are my restrictions? Because they would all make 0 in the denominator. I'm going to look for things I can cancel. So the x minus 5s. And here's the other part that kind of can throw people off. Isn't it true that I can rewrite 2x squared as 2x times x? So what would that mean for this 2x up here? It would cancel out with this, but it would, very good, it would leave an x. So my final answer would be x plus 3 over x. Oh, and then we have our plus 5. I forgot about that one. Sorry. X and then plus 5 from this guy right here. So if this were a multiple choice question, just be aware that they could have distributed the x out, right? So just keep that in mind. It would be the same answer if it were x squared plus 5x on the bottom. Does anyone have any questions about that? All right. So next one we're going to try, we're multiplying it by a trinomial. I just want you to understand, this is a fraction if you put it over 1. So I'm really just multiplying the tops with the tops and the bottoms with the bottoms. In this case, the bottom's just a 1, so it's not going to change the denominator at all. So it's really just going to be dealing with the numerator. Okay, so we have an x plus 2 on my top right here. I'm just bringing that over because it can't be factored or anything like that. And then I'm going to factor the trinomial, okay? So any ideas on how I can factor this trinomial?
6 and 2.
Good. Positive 6 and positive 2. Good. Now you don't have to write the 1 in the denominator, so really the only thing I have to worry about in the denominator is factoring this one here. So what is that going to factor into?
6, negative 1.
Good. Positive 6 and negative 1. Anyone have any questions about those? So what would be my two restrictions here?
Negative 6, positive 1.
Good. Negative 6 and positive 1, because those would both make my denominator 0. You can set it equal to 0 and do the math if you feel like you need to. That's fine. And now I'm ready to cancel out any terms that they have in common on the top and bottom. Any? Good. The x plus 6's cancel. And what's going to happen on the top there?
X plus 2 squared.
Very good. X plus 2 squared. So it wouldn't be wrong if you wrote them separately, but more commonly, if you're dealing with a multiple choice answer, you're going to see it written squared. So I just want to make sure you're aware of the different forms of how it can be expressed. So does anyone have any questions about that? Okay. So now we're moving on to number 3. So I have a lot to factor here. I'm going to factor the first one. Yeah, go ahead. You can take an x out. Very good. So if we take an x out, we're left with x times x minus 3.
I'm so sorry, can you go back to 2 really quick?
Yeah, sure.
Okay, thank you.
Mm-hmm. So is everybody good with what I did on 3 so far? Now we're going to factor this trinomial, and what's that one going to factor into?
So negative 4 and 5.
Good.
Nice.
Exactly. And then we're going to do this one. So what's that one going to factor into?
X plus 5, x minus 4.
Good. X plus 5, x minus 1. I think that's what you said, right? Maybe
Yeah,
you
that's
did.
what I
Oh,
meant
no,
to,
that's
that's what I
right,
meant
yeah.
to say. That's what I meant to say. My brain just like.
Ah, alright. I didn't know if that's what you said or not really. I was like, maybe? And then this one is just stays as is, because we can't factor that. Okay, so now we want to find our restrictions. So what are my 3 restrictions going to be?
X minus 5, x plus 1, and x plus 3.
Positive 3.
Yeah.
Why would positive 3 not work but negative 3 does?
Because positive, negative.
Yeah, if you had a negative 3, it would be 3 minus a negative 3, which would be 6. But what's 3 minus 3?
0.
So if I plug the 3 in, that would give me a 0. So like I said, if you're not sure, to find your restrictions, feel free to set them all equal to 0 and solve. Okay, so I just want you to all be aware that that's an option if you need to. Okay, and then just solve for x. So from here, we can now start canceling stuff out, right? We can cancel out these, the plus 5s. What else can we cancel out?
The root x.
X minus 3.
We can cancel these out, but at a cost. What's going to happen now?
X.
Becomes
Negative x.
negative x. Good. So when you decide to cancel with, they look the same, but they're flipped and it's minus, you have to put that negative 1 out there. So really what's going to happen is this gets replaced with the negative 1. So really this is just negative 1 times x minus 4 all over x minus 1. And then how can I rewrite this negative 1 times x? Can I just write it as negative x? Do you all see how that happened there? Okay. So you don't have to write it all out separately. You can just make something on the top negative. But I just wanted to show you for clarity purposes what was happening there. So does anyone have any questions about that? All right, you ready to try another one?
my mouth. No.
All right. So what can we factor out of this one?
0x.
Even bigger than that.
4.
4x. Which should just leave us with x minus 1, right? And then on this one, we can take, or we cannot take anything out, but we can factor it into two binomials, right? What two binomials would that factor into?
X minus 2, x plus 3.
Yes. Positive 3, negative 2 would work. And then for my denominator, first we have to take out a GCF. So I'm going to do this one off to the side. You're going to see why. So if I take out the GCF, I end up with this. Doesn't this factor again? Wouldn't this then factor into what?
X plus 3, x minus 1.
Good, x plus 3, x minus 1. So really, that's going to be its fully factored form. So I just did it off to the side so that we didn't have to rewrite the whole thing again, but so that's fully factored. So I know you might be thinking, oh, I should use the AC method here, but it's important. You have to only use the AC method after you've taken out any possible GCFs, or it doesn't work right, okay? So just be careful of that. And then lastly, I'm going to factor this. What's going to come out of the one in the yellow here?
4x.
Good. Going to leave me with x minus 2, right? All right, so we're at this point. Very spring colors. We're going for the... All right. So what are the restrictions here?
X equals negative 2.
Good.
Positive 2.
Positive 2.
And 0.
Very good. Anybody know where the 0 comes from?
4x.
Good, the 4x. And then now we can start canceling stuff out. What do you notice happened to the numerator?
It all got canceled out.
Which leaves me with a
1.
Mm-hmm.